So now, what's happening once I start to titrate? We have to account for the total volume change. So, after I add 10 mils of sodium hydroxide. So we think about this and we know that 1 HCl reacts with 1 sodium hydroxide. So I have to think about what was in my beaker and how much of it now, and how much is in moles. So what I put in my beaker to start, I had 50 milliliters of HCl, and the concentration of my HCl was 0.1 molar, 0.1 moles per liter. A liter is 1,000 mils. So I had 0.00500 moles of HCl in the beaker to start. And that's important. What else is important mathematically is significant figures. I have 3 sig figs in my 0.1 molar, so make sure you add those tailing zeros and that you're able to pay attention to your significant figures in this. Now, I added 10 milliliters of sodium hydroxide. So I had 10 milliliters of NaOH added. And it is also 0.1 molar. So 0.1 moles per 1,000 mils. So I added 0.00100 moles of sodium hydroxide added. Now, when I dumped in that sodium hydroxide, what happened to it? It reacted with the HCl. How much of the sodium hydroxide reacted? All of it. How much sodium hydroxide is left? None. How much hydrochloric acid reacted? The same amount of moles as sodium hydroxide. Okay, this is a very important concept. So that's equal to 0.001 moles of HCl used up. So what's left in my beaker now? What's left in my beaker is I had 0.005 moles of HCl, but I used up 0.001, so I have 0.00400 moles of HCl left in the beaker. Now, this is moles of HCl. pH depends on what? Molar concentration of the hydrogen ion. So I have 0.00400 moles, and now it's in a total volume of what? 60 mils. 60 milliliters is 0.06 liters. So I have 0.0667 molar HCl in my beaker. Now, this is important that everybody understands how I got there. I looked at the moles of each thing added. One of them got used up. That's Chem 111, Chapter 3, Limiting Reactant Problems. Now I calculated the molarity of what's left. That's Chem 111, Chapter 4, Solution Chemistry, right? And math. Now, the pH at this point in time is equal to the negative log of 0.0667 molar. So the pH at this point in time in my beaker is 1.176. So as I'm titrating, does my pH change? Yeah, it started going up. Did it go up a lot? No, it went up a little bit. So when we look at this, we're doing a titration, an acid-base titration. We have acid in our beaker and we're adding base. So we look at the milliliters of base that's added. And we look at the pH, and what we get is something like this. We start off, the pH goes up a little, then all of a sudden it shoots up, and there is this point of inflection, and this is the pH at the equivalence point. So you'll see the pH going up a little bit, and then all of a sudden it goes up a lot. And when we're looking at this, in an ideal world, this is the pH where the indicator changes color. But what happens if the indicator changes color here or here? Is that going to be a huge difference? Not really. Okay? All right, so we'll stop here and we'll finish this problem on Thursday. We will have some lecture before lab.